Okay, so today we're taking an angle that is not on the unit circle. So for instance, you see 105. Can you find the sine of 105 on your unit circle? No. The point of today is to be able to take an angle that is not on the unit circle and still find its trig value without using a calculator. Because on your quiz and test, you will not receive calculators. You'll have the Schoology 4-function calculator, but that's it. Now, one of the ways we can find the sine of 105 without using a calculator is by taking 105 and splitting it into two angles that are on the unit circle. Now, what two numbers that are on the unit circle could we break 105 into? 60 and 45. So I'm going to write here sine of 60 plus 45. Now this does not mean, don't write this when I write under the dotted, this does not mean that sine of 60 plus sine of 45 is going to be the same thing as sine of 105. These are not the same. Instead, we need to use one of these identities on our little pink sheet. Now, if we're adding two angles and taking the sine of those two angles, which identity is that under the sum and difference identities? The first one, yeah. Sine of x plus y equals sine of x cosine of y plus cosine of x sine of y. So if I'm looking at my sine of 60 plus 45, the 60 is like my x value and the 45 is my y value. So I'm going to rewrite this trig function using my identity. It states that sine of x plus y is equal to sine of x, which in this case our x value is 60, times cosine of y, our y value is 45, plus cosine of the x value, which is 60, times sine of the y value, which is 45. Ooh, I wrote really crooked there. Oh, good. Okay, so what is, because all of these angles are on the unit circle, we can actually know the sine of 60 without using a calculator. What is the sine of 60? Looking at our unit circle, or even just remembering what the sine of 60 is. Yes, square root of 3 over 2 times, what is the cosine of 45? Root 2 over 2. Plus, what's the cosine of 60? 1/2 times the sine of 45. Good. So now it's just simplifying. It's just algebra. How do I multiply? If I'm multiplying square root of 3 over 2 times square root of 2 over 2, how do I multiply those together? Yeah, you multiply the top and the bottom separately. How do I multiply two radicals? Yes. You just multiply the number under the radical. Good. So 3 times 2 is 6. Square root of 6. And then what does the denominator become? 4. 2 times 2 is 4. So then what does the right-hand multiplication become? Yes, square root of 2 over 4. If you've done this correctly, you should end up with like denominators so that you can immediately add these together. Now, how do you add square root of 6 over 4 plus square root of 2 over 4? It works differently than multiplication, actually. Can they be combined? No. You kind of treat radicals, I know I hate to say this because they're not, but you treat them like they're variables, okay? They're unlike terms. Square root of 6 and square root of 2 are unlike terms. They can't be combined. You just write them next to each other. Just like if you had x and y, if you're multiplying x and y, it becomes x, y. But if you're adding x plus y, they don't combine. It's just x plus y. Same concept. All right. Let me go ahead and get you started on the next one, but I'm going to have you finish it. Cosine of negative 45. Yes, this is on the unit circle, but let's pretend it's not. We're going to break it into two angles that create negative 45. What two angles create negative 45? What's that? So, yes, however, I'm going to tell you, try to always use two positive angles with a subtraction between. So think of two positive angles that are subtracted to create negative 45. Yeah. So that's what I'm saying. You can on the units. So I know that this angle is on the unit circle, but for purposes, I wish that they hadn't given it on the unit circle. Let's pretend it's not on the unit circle and give me two positive angles that when subtracted give negative 45. Yeah, I would do, either one of those would work. I like 45 minus 90. You could also have done 0 minus 45. It's 40. Why is it 45 minus 90 instead of 90 minus 45? You need to have it be negative. You will end up with the same answer, but you wouldn't get full credit. Okay, so here, which identity am I using? It's a different identity, guys. Pay attention. It's cosine subtraction. Which identity am I using? Good. That fourth one down. Cosine of x minus y. So this is my x value, the 45, and the 90 is my y. Notice, I am just inputting 90, not negative 90. Am I being clear? Maybe. We'll see. So the identity states that it's cosine of x. What's my x? 45 times cosine of y. What's my y? Just a positive 90. Yes. I saw that a lot yesterday. So many people tried to put negative 90 there. No. The minus sign just determines the identity, okay? Plus sine. Oh, why am I doing this? I wanted you to do it. So yes, you guys got the right answer. Now, to finish this off, just really quickly, we had sine of 45 times sine of 90. And in the end, you guys got square root 2 over 2. Okay. Now here, it gets just a little bit tougher because our minds do not easily translate to radians, which is okay. Now I'm going to show you two ways. I'm going to show you two ways to solve when you have radians. One is to just deal with it and work in radians. The second way is to change radians to degrees. In this case, it will not matter whether you work in radians or degrees. You'll still end up with the same value in the end. But first, let's try working in radians. How can we take 19 pi over 12 and split it into two fractions that are on the unit circle? Yes. Yes, I think you're on the right track. Right, yes. Now, instead of, you're kind of working backwards from how I think this naturally flows, but if instead you think of this as splitting into two fractions that have 12 as the denominator, both have pi, that add to be 19, that then reduce, when you reduce the fractions, they reduce two fractions that are on the unit circle. This is hard. Okay. So we're using the angles 5 pi over 6 and 3 pi over 4. What identity are we using here? Which one on our pink sheet? Good. The third one down, cosine addition. So this is our x and this is our y. So we have cosine of the x value, 5 pi over 6, times cosine of the y value, which is 3 pi over 4. Then the identity states that this is now a subtraction of sine of x, 5 pi over 6, times sine of the y value, 3 pi over 4. Okay, so what is the cosine of 5 pi over 6? The cosine. Good. What's the cosine of 3 pi over 4? Good. Minus, what's the sine of 5 pi over 6? And then what's the sine of 3 pi over 4? Good. So now, what does the left multiplication give us? So it's positive, and the denominator is 4. Minus, what do we have here? So what is our final answer? Good. Oh, yeah. All right, so now, if that totally blew your brain, working in radians, it's okay. In this case, because we're taking sine of the angle, it doesn't matter what unit you work in, degrees or radians. We're taking the sine of it, it should produce the same value. So we're going to go ahead and take radians and convert to degrees. How do we do it?
Oh, no, something plus 180. Pi over 180.
So think of this. Hold up, because fourth period also came across this issue. I know for a fact that you guys learned those big long conversion statements with like multiple conversion fractions.
Oh, yeah.
Is this unit radians or degrees? Radians. In order for the radians to cancel out, where does the radians have to be?
On the bottom.
Bottom. Shh. So where do I put the radians?
On the bottom.
Oh, thank you. So what goes in the denominator?
Pi.
Yes. And what goes up top? Yes. So you do have a 4-function calculator on Schoology. What does this become? Yeah.
Wait, Matt.
What does it become? -75.
Oh, really?
Yeah.
It just comes out to a
Yeah, pretty number. It has to come out to a pretty number, guys, because then you couldn't use these sum or difference identities. Yeah. Equals negative 75. The sign's out in front. We're just multiplying these two together to convert to degrees. So negative 5 pi over 12 times 180 over pi becomes negative 75. The pi's cancel. All right. You guys complete this problem. What two angles did you guys come up with to create negative 75? Oh, those are all beautiful. You see, there's many different angles we could have chosen. I did 60 minus 135. So then once we create the identity and we subtract and multiply our fractions, what should you have ended up with in the end? And that's what you should have gotten as an answer. You could also have gotten negative square root 2 minus square root 6 over 4. Those are the same thing. Yeah, you can. This is the same thing as this. Oh, what is that identity called when you can switch them? Math is, yeah. I've never taught it, so I don't remember it. Okay, reflexive?
Oh, wait, maybe.
I think it's reflexive. Addition and subtraction are reflexive, meaning you can flip the values and it stays the same. All right. So we're trying to find the tangent of 15. What two numbers can you think of that are on the unit circle that either add or subtract to give us 15? Yeah, we could have done any of those, but I like 45 minus 30. Now, what identity are we using? The tan subtraction. Good. So this is our x and this is our y. So we have tan of 45 minus tan of 30 over 1 plus tan of 45 times tan of 30. This equation is coming from on our pink identity sheet. It is the sixth one down from sum and difference. Okay. Now, can we immediately look at our identity sheet, our unit circle, and find the tangent of 45 and the tangent of 30? Are they written right on our unit circle? No. How do we find tan on or for any angle? What do we do? Y over x. Sine over cosine. So, let's preemptively, before we start this, find the tangent of 45. What is our sine value, our y value at 45? Root 2 over 2. Over, what's our x or cosine value? And what does that simplify to? 1. That one's easy peasy. Let's now do the 30. What's the sine value? And cosine? Can you immediately see how that reduces? I can't. What do you do to reduce a big fraction? Good. Multiply by the reciprocal, which is 2 over square root 3. So we have 1/2 times 2 square root 3. What happens? The 2's cancel. What's wrong? Good. We need to rationalize this denominator, it's called. How do we do that? Multiply by the square root of 3 over the square root of 3, and what do we get? Good. So the tangent of 30 is root 3 over 3. So now I'm just going to take these two values and plug them into my equation, my identity. What was the tangent of 45 again? Minus, what's the tangent of 30? Root 3 over 3 over 1 plus tangent of 45? 1 times tangent of 30? Does this look fully reduced to you? No. What do you think I have to do to fully simplify this fraction? Yep, you can multiply 1 times square root of 3 over 3. Would that be fully reduced? No. What do you think you're going to have to do? So yes, eventually we're going to have to multiply by the reciprocal to get rid of the big fraction. But before we do that, we need to have a single term in the numerator and a single term in the denominator. You can't because there's addition and subtraction between. Only when there's multiplication can you cancel. Yes. And why are you doing that? Yes. We are trying to first combine 1 minus square root of 3 over 3, right? We're combining these two. The only way we can combine them is by getting them to have like denominators, meaning you're multiplying this by 3 over 3. So we get 3 over 3 minus square root of 3 over 3. What can now happen there? It's harder. Like, why would you multiply by square root of 3? Okay. So here, we end up with 3 minus root 3 over 3. All over, there's a lot of 3's here. We do the same thing in the denominator. We're multiplying the 1 by 3 over 3. And we get 3 over 3 minus square root 3 over 3. Oh no, oh my God. No one yelled at me. Plus square root 3 over 3. And it becomes what? Good. Oops. So, why did we do this? Why the heck did you work on combining those? What can we now do? Yes. Yes. We can now get rid of the big fraction. How? Yes. 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 You multiply by the reciprocal of the denominator. What happens here? What do you notice? What cancels? No. Almost. The singular 3's. Why does 3 minus square root 3 and 3 plus square root 3 not cancel? One's a negative and one's a positive. Why can we not do this?
Because they're with the other one.
Yes, they have addition and subtraction between the terms. You cannot cancel when there's addition and subtraction between terms. Has to be multiplication, okay? Now, what does this become?
3 minus root 3 over 3 plus root 3, but we need to rationalize it.
Yes. I know. Bear with me on this problem, please. I'm so sorry. I told you it was a beast. All right. So you recognize we have a square root in our denominator, can you just multiply by the square root of 3 over the square root of 3 and have all square roots cancel? No, unfortunately. Does anyone know what we do to get the square roots to cancel? You technically learned this or talked about it last class. So, it's called multiplying by the conjugate. Did she say those words? No. It's okay. All that the conjugate is two terms with a different sign between. So if I'm trying to get rid of my denominator, I'm trying to get rid of that square root of 3. Right now my denominator is 3 plus square root 3. I'm going to multiply by the conjugate of 3 plus square root 3, which is 3 minus square root 3. Bear with me. This is called multiplying by the conjugate. It's okay, you don't need to remember those words. How do you multiply 2 terms times 2 terms? A binomial times a binomial. FOIL. I like to call it double distribute. What is 3 times 3? 9. What is 3 times negative square root 3? Good. And then we also need to remember to multiply the negative root 3 times both of those terms. What is negative root 3 times 3? Negative 3 root 3. And what is negative root 3 minus root 3? This last one. Negative root 3 times negative root 3. Positive 3. Good. I'm sorry if you're running out of room, by the way. What does that simplify down to? We combine these two and we combine these two. 12. 6. We're not multiplying, we're just subtracting. 6 root 3. Okay, we have to again multiply the denominator. What is 3 times 3? 9. What is 3 times negative root 3? Then, what is root 3 times 3? Positive 3 root 3. And what is root 3 times negative root 3? What happens here? Oh, thank God. This is why we multiplied by the conjugate, because the roots will cancel. The middle terms will cancel. And what's 9 minus 3? 6. However, can this be simplified? Yes. What goes into 12, 6, and 6? 2. Bigger. 2 minus 6. Right. 6 goes into all 3. Right? So this is a 1, this is a 1, this is a 2. We end up with 2 minus root 3, and we're done. I am so sorry. What identity is number 6? It's cosine, cosine, plus sine, sine. Shh. Cosine, cosine, plus sine, sine. Which identity is that? Oh. Okay, now that you've had a chance to think about this, we're looking at the right-hand side of our identities. We're looking for an identity that has cosine, cosine, plus sine, sine. What identity is that? It is the sum of, it's difference of cosine. It's that fourth one down identity. Cosine of x minus y. So what's our x value? 94. What's our y value? What is 94 minus 18? You're done. Cosine of 76. If you do this and the number ends up being on your unit circle, you'll have to provide the value on your unit circle. So for example, if it gave you cosine of 45 in the end, you'll have to write square root 2 over 2 in Math Excel. So look at number 7. Which identity is sine cosine minus sine cosine? Difference of sign. So we have sine of pi over 3 minus pi over 7. Can you immediately subtract these? What do you need to do really quickly? Get a common denominator by multiplying by the other denominator. So we have sine of 7 pi over 21 minus 3 pi over 7. 21. What is 7 minus 3? So we have 4 pi over 21, and we're done. And in case you're curious, in case you want to check yourself doing number 8, you should end up with, in the end, tangent of 75. Okay, one last one really quickly. I wasn't going to do this problem, but in 4th period, a lot of people were having trouble with it because it combines what you did yesterday or last class and what you're doing today. Right now, we're trying to prove that cosine of pi over 2 minus x minus y is equal to sine of x plus y. Which side would you like to change? The left side, to make it the simpler side, the right side. So, we have an angle, which we'll call this angle A, right here. This is an entire angle, and this is angle B. We can use the difference of cosine to simplify this. So I'm going to use the difference of cosine identity and have cosine of pi over 2 minus x times cosine of y plus sine of pi over 2 minus x times sine of y. All I did was use difference of cosine identity. Now, what do you know cosine of pi over 2 minus x is? Yes. If you look at the front of your pink sheet, you know that by the cofunction identities, cosine of pi over 2 minus x is the same thing as sine of x. So this is just a cofunction identity. And then we have cosine of y plus, now what is sine of pi over 2 minus x the same as? Cosine of x times sine of y. What is this? Sine of x cosine y plus cosine x sine of y. What is this the same as? Sine of x plus y. How do you know that? That is the sum of sine identity that we worked on all today. Sum of sine identity. So that equals, I guess I did my line way too far over, sine of x plus y, and we're done. Do you guys know how to end a proof? Like, yeah, this is the last line of the proof, but how do you denote a proof is done? No. No one ever taught you this in geometry?
Sure they did, but we don't remember.
So, kind of like diagonal to the right from your very last statement, you either write QED. Do you remember that?
No.
Or, and I like this better, you do a little box that's half shaded. Obviously, do you need to know this? No. Is this what they use in proof colleges and math? Proof colleges. Is this what they use in proof classes for math in college? Yes.